Hi there, welcome to the channel. I'm Mrs. R. Let's do some math. Today we're talking about one-step inequalities. Now the instructions for this one, we're going to solve each inequality, but we're also going to graph its solution. So if you need a refresher on graphing the solution, check the top of the screen. There should be a link to our graphing inequalities video. Now solving inequalities is very, very similar to solving equations. We have two sides split by a relation, in this case a greater than sign, but we can still do things to both sides as long as we keep it balanced by doing the same thing to both sides. So I'm going to rewrite this where I have a little space. Negative 12 is greater than x minus 7. Now the goal when solving is still to get the variable by itself and then a number on the other side. So we'll use our inverse operations to clear out that negative 7. It said x minus 7. We'll use our inverse operations to cancel those to 0. On the left, we do negative 12 plus 7, and that gets us negative 5. And we bring down that same inequality sign, so it's still greater than, and then there's our x. Now, technically, we have solved this. This is our solution. Negative 5 is greater than x, but now we need to graph this. So we'll find where negative 5 is on the number line. Be right there. And we see that this is strictly greater than. There's no equal to. So we'll use an open circle. And we want the negative 5 to be greater than all of the x's. So this is the same thing if we flip it as x being less than negative 5. So we're going to shade to the left. And there we've solved it and graphed our solution. Let's do another example. Now this one doesn't have any hints. We're going to fill in our own number line. But we've got our 15 minus x is less than or equal to 0. Now we have some options on how to solve this. I'm going to do it two different ways because I need you to see something on this problem. So the first thing I'm going to do is the first thing that a lot of people do. They say, well, there's the x, so let's get rid of the 15. And it's positive 15, so we'll subtract. And then we have negative x being less than or equal to negative 15. And here's where we kind of get stuck if this is the way you've started it, because now we have a negative x, we need to just know x. But if you think about this as the opposite of x, because really that's what negative x means. If it's not subtracting from something, it means the opposite of x. So if x is a positive number, then the opposite of x is negative. If x is a negative number, then the opposite of x would be positive. Now we need this to be whatever the opposite of x is, we need that to be less than or equal to negative 15. So I'm going to make kind of a sidebar here. So if we have negative 15, less than or equal to that, this is where negative x would be. So if we imagine the positive version of this, we'd have to consider the positive version of x, but also the positive version of 15, because the opposite of x is less than or equal to the opposite of 15. So this would be almost the same thing as putting a positive 15 there and saying x is over here. So really what this is going to turn out to be is that x is greater than or equal to positive 15. And I know that's kind of a weird way to think about it. So I'm going to show you another way, and then we're going to kind of bring these two ways together to give you a rule that you can use every time. So we did find out that thinking about that opposite idea did give us x is greater than or equal to 15. Let's look at the other version of this. So the 15 minus x being less than or equal to 0, maybe you don't even want to deal with the negative x. You don't want to have to worry about, well, what do I do with negative x? So let's use that for our inverse operation first. We can cancel the x's on the left-hand side. 15 is left. We bring down the inequality, just like we always do. And 0 plus x, well, 0 isn't going to change anything when it adds, so we just get x. But 15 being less than or equal to x is the same thing as x being greater than or equal to 15, which is what we had down here. So the second method was a little more straightforward, but it's not always the first step that most people would jump to. That's why I wanted to show you both. Now, as far as a rule that we can use that this kind of leads us to, when we had that negative x and the negative 15, instead of thinking of, well, in abstract language, this means the opposite of x, because that's really awkward for some people. The other thing you could do if you wanted to keep dealing with more of the standard algebra steps, we could multiply or divide, both of them work actually, by -1. So now we have a negative divided by a negative. That gives us positive x on the left. On the right side, negative divided by a negative, that'll give us positive 15. Yeah? But then, if we just brought down that same inequality, we would not have the right answer, would we? We know, we've done it 2 different ways already. We know the answer is supposed to be x is greater than or equal to 15. Which means if we divide by a -1, we have to flip the inequality. The same thing will happen if you end up multiplying both sides by a negative. You'll have to flip the inequality because you're basically working with that opposite idea. Your x kind of should have moved to the right-hand side like we did over here, but you didn't move it, so we flip the inequality. It's kind of how it works. So that idea, just as a reminder, as you're solving inequalities, whether they're single step, 2-step, multi-step, anytime you multiply or divide both sides by a negative number, flip the sign. Flip the inequality sign. Now, there are almost always ways around this if this is a rule that you just don't understand and you don't want to use a rule you don't understand. I totally am with you. I am the same way. So remember, we had this option over here where instead of having to deal with a negative x, I used my property of equality to add x to both sides, and then I was working with a positive x. I never had to divide or multiply by a negative there. So pretty much every problem that you try to do, you would have that option. You just have to think ahead a little bit to see if any negatives are going to come up. So we have our answer. We've solved it. X is greater than or equal to 15. We would just need to fill in the number line. Let's put 15 there. We'll go 14, 13, 12, 11, 16, 17, 18. So we'd put a solid circle on 15 because we do have that or equal to, and we need all the x's that are greater than. So we'd shade to the right. All right, I have one more example. Here we go. We'll leave this rule up here so we remember. Anytime you multiply or divide both sides by a negative number, flip the inequality. So we have 32 greater than or equal to -16 times p. Now, if you want this to be a one-step equation, you're going to have to divide by -16. If you don't mind 2 or 3 steps, there are other ways to do this. But if you are just going for speed, you have to make sure you remember our little rule about dividing by a negative. So our -16s will cancel. 32 divided by 16 is 2, so with the negative there, we'll have -2. Now remember, this is where we flip the inequality sign. We divided by a negative, so now we're going to flip it. And then there's our p. So as long as you remember to flip the inequality, that was a pretty easy problem. And then we'll graph it up here. We find the -2. We do want to use a solid circle. And we want the -2 to be less than all the p's. So we're going to shade in the right side because p's are going to be greater than 2. Now, just in case you're curious, because I did say that you could avoid the whole divide by a negative thing if you really wanted to. It just makes some people uncomfortable because what I'm going to do here is add 16p to both sides. So that's going to cancel out this entire term on the right side. We're going to end up with 0 there. And since there's nothing else there, we're actually going to have to write the 0. And it freaks some people out. But then we can keep the same inequality, not have to worry about it. Our terms here, the 32 and the 16p, are not like terms. So we'll just have to write it as 32 plus 16p. And now it looks like a 2-step inequality. Put a link up at the top for that so you can jump straight to it if you need to. And now we've kind of just flipped everything around without flipping the inequality. We'll divide by 16. So we have our p is greater than or equal to -2, which is equivalent to -2 being less than or equal to p. So that is how you work one-step inequalities and graph them, and how you can handle that negative idea in 2 different ways. Remember, we do have that rule, anytime you multiply or divide both sides by a negative number, you flip the inequality. But there are ways around that. You just avoid multiplying or dividing by a negative if that's a tough rule for you to remember. So thank you so much for watching the video. If you found this helpful, please like on the page so that we can get our videos out to more people. If you still have questions, or if you have another concept that you'd like to see made into a video, please leave a comment and we'll address that as quickly as we surely can. Well, I'm Mrs. R. This has been me doing math, and I'll see you guys next time.